Hey, what's up, Ziguanas? This is day 16 of the 30 days of Zig Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years, more or less, of professional coding. Well, yeah, professional because I took money for it. Coding experience, co-teaching experience, sorry. My name is Dusan. Welcome to United. And today it was a fun stream where I summarized the first 15, more or less, the topics of first 15 days of my Zig voyage so far. Thanks for the guys that helped me with pointers and arrays and slices, Robert and Andre. And I went a bit fast because by accident I closed the stream before I actually went to the last screen. I had some bug, like it's not entirely my fault. Since the beginning I had some problems, so it created like 2 streams instead of just one, and it was something weird. So yeah, a little bit of my fault, a little bit of bug, and that's how it is. So now I'm going to jump straight into the next topic, which are optionals. Let's see what they say about optionals. One area that Zig provides safety without compromising efficiency or readability is with the optional type. The question mark symbolizes the optional type. You can convert a type to an optional type by putting a question mark in front of it like this. Like this. Okay, let's do that. Yeah, this is from literally 2 hours ago. Playing with Zig and tic-tac-toe. But let's now do this. Normal int and optional int. Okay, let's copy them both. And let's print both of them. And I want to see the type off as well here. So then, first of all, this one, and then type of this thing, and the same for the other one. It's normal, so let's actually print first the normal. Here, yeah, I did print, yeah, normal, my mistake. I thought for some reason I printed first the optional, and let's run. What did it say? Ah, okay. So let's do here. For the optional, actually, let's try here only. Let's just see how this will work. Will break. Yeah, it's fine. Okay, so optional needs something like any. And let me just do a new line. Okay, so the value itself is what you can probably expect, and the type is also like literally they are saying the same thing, question mark and I32. So I guess this is officially optional I32, right? So let's see what else they say about it. And now the variable optional int could be, aha, this is the difference. It can be I32, yeah, or null. Okay. Now the variable, okay, instead of integers, let's talk about pointers. Let's do that. Null references are the source of many runtime exceptions and even stand accused of being the worst mistake of a computer science. Yeah, heard about that, kinda. These polemics about this. Zig does not have them. Null references, okay. Instead, you can use an optional pointer. This secretly compiles down to a normal pointer, since we know we can use 0 as the null value for the optional type. So basically 0. Okay, but the compiler can check your work and make sure you don't assign null to something that can be null. Typically, the downside of not having null is that it makes the code more verbose to write. Yeah. But let's compare some equivalent C code and Z code. Task call malloc to allocate memory, and if the result is null, return null. Oh, it's been a while, like since I did C. Okay, pointer malloc size t size struct foo do a thing void character is pointer to malloc1234. If not pointer, return null. Okay. And Zig, let's actually compare them side by side. Hello, Robert. Long time no see. Yeah. So not that much different. I mean, the number of lines. Extern function malloc size, use size, optional type, the pointer. So this, like, I still mix these things. So I'll definitely have to go one more time through pointers. So if it's a star inside, is this one many item pointer? Yeah, okay. I confuse, like, this one I kind of memorized immediately, but these three and those are the ones that I mix, like when it's a slice, when it's an array, like the syntax, I still confuse that part. Let's go back to, went too far. Assembly, so it's not assembly, it's before here, options, okay. So, many items, okay. Optional many items, pointer to 8. Then function do a thing, which is optional pointer. Yeah, definitely. It's how, because now I even confuse without the optional part these things here when we speak about pointers in RS and slices. So definitely, if I now introduce question marks for optionals, I will definitely confuse them if I don't memorize these things first. Not that optionals are overcomplicating things, but simply because this base is still missing in my mind. Do a thing, okay, it's a pointer to foo type. Constant pointer equals malloc1234. Yeah, I even didn't play with this yet in Zig. In C I did it, but while ago. Or else return null. And then they dump the pointer, okay. Here Zig is at least as convenient, if not more than C. And the type of pointer, so I guess it wasn't the point in the length of the code. I was just like maybe distracted by that because they said here the typical downside is code is more verbose to write. But this is, so I expected much worse than what they have here. But actually it's okay, it's not bad. Here is at least as convenient, if not more. Yeah, true. And the type of pointer is this one, not. Aha. Okay, these are these tricky little details that I will confuse for sure. We also, so let's see, first of all. Okay, so they didn't specify that here. If the type is the optional type itself, how they kind of read it. Do they read this like it's the optional type is i32, not the question mark i32? Maybe it's the same, maybe it's a bit different. In general, use normal pointers to do things in slices. The rest are nice, but less agronomic and less safe, mainly for C. Aha, so that's why they... Okay. Yeah, it makes sense, because they wanted to be as compatible as possible with C and low-level stuff. Okay, thanks for the explanation. I was here, right? The URL's keyword, this one here. Unwrapped the optional type and therefore pointer is guaranteed to be non-null everywhere it is used in the function. So it's unwrapped there and guarantees. So this mechanics, I guess, in the entire thing guarantees to be non-null, because otherwise you return null, right? So okay, and in this case, let me just double check here. So they create this malloc. I mean, they included it from Zig code base just for reference, which is helpful. So it creates, it takes only one parameter, uSize. So this is the size, okay. Then it returns. So I guess this is like in other languages, just like, so they here call it prototype. If in other languages, they call it these things like interfaces and similar, when you don't have a body, but you just like have the signature. So I guess this is what it returns, right? And then they will try to assign whatever this malloc returns, and that is this thing here, which is an optional pointer, which means it can be null. So then it means either it will be pointer or null. So this kind of like sounds redundant. So I know that there's something that I'm missing, but because here I would think if I didn't see, if I haven't seen this, I would just think this is enough. If you say that return type is optional, that if you do something like this, it's enough, because you can get, maybe this is just like more on the high level. They want to propagate this so that it's not only here, but that this thing kind of like returns null. That's the point, that they focus on that. Okay. Also being able, just reading comments, to define non-nullable pointers is insanely convenient. Yeah, yet you still can have nullable ones just by adding. Okay. Yeah, makes sense. Here, Zig is at least as convenient, if not more, than C. And the type pointer is, wait, did I just reread? Yeah, sorry. In Zig, you can accomplish the same thing. Okay, just kind of trying to compare what they did there and what they're going to do here. Const foo is equal to the struct, which is an empty one. Then they have a function, do something with foo, they receive the pointer to foo, not returning anything, and then just like they dump it. Okay, do a thing. Okay, now so a few days ago when I first saw something like this, like the same name of the function here in docs, I was reading this like do at, something like this in my mind, but this is like do a thing, like but because of the casing, it looks like 80. Okay. So do a thing, basically. Optional foo. Okay. Then they change the type here. That is pointer to foo or null, right? And then void is return type. Okay, do some stuff. If optional foo, which basically means if it's not null, they then have this capture group, and they will just like do something. They call this function which will do something. Okay, yeah, nice. So basically it's very clean to check if it's a non-null, to do something. Once again, the notable thing here is that inside the if block, foo is no longer an optional pointer. Yeah, so it's unpacked, unwrapped, how they call it. It is a pointer which cannot be null. Yeah, Yeah, so that makes the difference. It's a non-null pointer for sure. One benefit to this is that functions which take pointers, yeah, basically now they're focusing on these pointer types which are optional, because it's not that much fun with the regular ones, like at the beginning, I32, which is not a pointer. One benefit of this is the functions which take pointers as arguments can be annotated with a non-null attribute in GCC. Okay, compiler. The optimizer can sometimes make better decisions knowing that pointer arguments can not be... Okay, the optimizer. Okay, makes sense. Option type. An option is created by putting a question mark in front of the type. You can use compile time reflection to access the child type of an optional. Okay, let's see what they do here. Test option. Okay, var foo is optional I32. And they set it to null. What they did before, they set it to number, if I'm not mistaken. Yeah, to a number here as well as here where it's optional. So now they set it to null, because basically this allows that it's either I32 or null. Okay, coerce from child type of an optional, foo equals... Aha, this is what they meant. From child type. Okay, because this is still an optional, so the type of the foo variable, it's still an optional. It doesn't matter that we assigned a null here. It still can take an integer, I32 specifically. That's what they mean by saying child type. So because this is kind of like a union of two types, right? So not maybe officially a union, but similar concept. Then compile time reflection to access the child. So this is the interesting part. So first of all, they take the type foo. Then they call this type info built-in. Then they get some struct probably. Then they take the optional field of that struct. Then the child field of that one. And then they test if it's I32. So it's still... So it looks like they still have in the type itself a reference not only for the value, but they also store the childs in this way. Like, this is interesting how they store things, information about what are the types that are allowed here, that they are like nested in this struct. So I can run this just to see for myself, and let me see what you guys write. The showcase is not ideal. They generally focus on showcase of usage and not on real-world code examples in the language docs. Yeah, so they are... I mean, I understand them. The docs are not usually focused on these kind of things, so they are trying to express as much things possible in a short space, and they don't widen the story because it can go very wide. The only like documentation in my life that I read that is so detailed with the real world examples is basically not for a language but for a framework in Python called Django. So this is probably the best documentation that I've ever read in this context, like what they described and how you can use the things from the documentation. But yeah, this is kind of like the usual docs situation, more or less. Let's run this thing here. I will delete everything except for the last part so that I can copy paste print. R4 K for 1 to 3. So I will not try, I will print from here. and it's a type. So I forgot if this will work without any. Let's see, I think it will. No. I keep forgetting to delete the things. Yep. I've read some decent C#. I never read C# documentation, so I learned it when I was studying, but I never used it, so I literally forgot it. Like few days after my exam, I completely forgot everything that I learned about C#. I never used it in my work. So I used mostly Java on the backend when I started backend, and then I switched to Python as my main language. And when I did frontend, of course, it was JavaScript at the beginning. By the way, I know I'm repeating myself, but siglings are much more focused on the practical side of. Yeah, that's great. I'm going to jump there next as soon as I go like through these basic things from the docs here. That would be a perfect next stop. Thanks. You're not like repeating yourself. It doesn't. It's a good thing because maybe some people who are watching this video haven't watched the previous one where you mentioned it. Thanks for that again. So okay, this is what we expected, right? Then let's see what's next. Null, just like undefined, null has its own type, and the only way to use it is to cast it into a different type. Yeah, that's what they did. So they casted, I mean, before in the example, so they casted null into the optional. Okay, option pointers. Option pointer is guaranteed to be same size as the pointer. The null of the optional is guaranteed to be address 0. Okay, they kind of mentioned that above. Let's see what they want to do here. Pointers cannot be null. If you want a null pointer, use the optional prefix to make the pointer type optional. So that's what they did here. It's a pointer to iterate2 but optional. Okay, then x is pure iterate2. Then they point a pointer to this x, which can be, because it can be either iterate2 or iter2 or null. Then they, oh, this is so cool, like dot question mark dot star. Looks like ASCII art. They go into the pointer, they take the optional and then dot. So this is like so weird, but I kind of like it. And then they take the address. Yeah, because it's kind of like a nested. So when they create this optional type, the types are nested in a way as childs, like how they call them. Option pointers are the same size as normal pointers because pointer value 0 is used as the null value. Okay, let's test these. I don't know why I left the first one. So let's print first this one here. And also for the type. For the size, sorry, not for the type. So I will do actually both. I will do this and I will also see a size just for fun. And one more time, print here. So what I wanted to do, this only. So this is the optional, right? Yeah. And this is the size of, okay, integer 32. So this one, I just want to see the size. I mean, I guess it's going to be the pointer. Actually, that depends on the architecture more. If it's a pointer to byte32, it means like how many bits you can use for the address, basically, not for the type. So it's not related directly to the type, unless in some structures like arrays where you have some offset. So I don't know how actually they did that under the hood, but let's see. Okay, and let's delete this part. Eight. So 8 bytes, I guess, which means because it's 8 bits per byte, right? So it's 8 times 4 would be 32. But like I said, it doesn't reflect the size of the type it points to. It points to the size of the address, which in this case it's 64. Okay. And this is true. And this is 1. Yeah, because they assigned it here, the 1. Just let me see what you guys wrote. C# docs are huge, so it's varying a lot. But they generally have a lot of examples. Yeah, that's cool. It's just highlighting that nullable pointers are memory free. That the nullability does not cost anything extra memory-wise, like in other types. Yes, it's 64-bit system, so 8 bytes pointer. Yeah. Thanks for explaining. Let's see what's next. Casting. Oh man, I'm like streaming 30 minutes. I just want to see how long this is. Well, at least I can start if it's a huge section. Well, let's just start at least. And what's after? It's 0-bit types. I think we did that, yes. Result location semantics. Namespace comp time. Assembly. Basically, that's almost it. Okay, asking functions for asynchronous work. Actually, yeah, there are quite a few things left remaining. Okay, let's see. Casting type cast converts a value of one type to another. Zig has type coercion for conversions that are known to be completely safe and ambiguous, and explicit casts for conversions that one would not want to happen on accident. Okay, yeah, so in some language this is called like implicit conversion and explicit conversion or cast. So here they call it coercion, okay, if it's safe and unambiguous, and otherwise they say it's explicit cast. There is also a third kind, okay, of type conversion called peer type resolution, for the case when a result type must be decided given multiple operand types. Okay, probably more complex example. Let's see from these first examples first. Type coercion occurs when one type is expected but different type is provided. So they have a const which is u8. Okay. And then they want to assign that u8 into a variable, actually in a const that, to a const which is u16, which is safe because they are doing it to a larger type from a smaller one. So that's why coercion, because it's safe, and then they dump b. Okay, so let's actually I'll copy all these, and then actually do I have to? It's so simple. Yeah, let's save a bit time. I don't even have to run. This is a bit simple. Then the next example is they start with u8 being 1. They call a function foo with that a, which is u8, but the function expects u16. And then they have the same coercion during the runtime when they call function. Okay. Then let's see what they do here. So the same start, but later they create b, and then they explicitly use as. So it's still called coercion, even though they are explicitly doing it now. So it's not that explicitly is determining if they're going to call it coercion of or cast. It's if it's safe, let's say, or not. Okay. Type coercions are only allowed when it's completely ambiguous how to get from one type to another. Like in this example, from smaller to a larger type of the same kind. And the transformation is guaranteed to be safe. There is one exception, which is C pointers. Of course, there is an exception. See what they do next. Stricter qualification. Values which have the same representation at runtime can be cast to increase the strictness of the qualifiers, no matter how nice the qualifiers are. Okay, const, non-const to const is allowed. Okay. Volatile. The opposite is not. So that's why today, I remember from the code today, it was kind of the opposite. Volatile, non-volatile to volatile is allowed. Okay. Similar reasoning. Align bigger to smaller alignment is allowed. Error sets or two supersets is allowed. Yeah, I remember this. These casts are no ops at runtime since the value representation does not change. Okay, that's cool. Then no op casts. What they do here, they start with i32 and then they take the address of A and set it to a pointer of i32. Okay, and they coerce, no problem there. And then they call B, which is a constant. And here it was a variable, right? Okay. And this is not what they meant here, I believe. Okay. Then in addition, pointers coerce to const optional pointers. Yeah, this is actually, so I was kind of like going a little bit ahead of time. So yes, they explained the basics of arrays and slices before, but today I was struggling with this casting part because I basically didn't go through these, which would make it a bit easier today, but it's okay. In addition, pointers coerce to const option pointers. Okay. Let's see what they do. So let me at least copy paste. I don't want to run it, but I'll just paste here because it's a bit larger font here so that it's more visible if someone is watching on the phone. Let's see what they do. Const window name. Okay, a lot of things happening here. So first of all, this is u8 window name, so string literal, which basically creates this array of u8s under the hood. And then they zero terminate, if I'm not mistaken, that this zero means that. Then take the first element, right? Window name, that's the constant. So let me see the next two lines, maybe I will understand better. Then they take the constant, they create a constant x. Okay, this is so hard to read. Let me see. So first of all, they take the address of the previous one. Then they have the constant u8. And then they have the optional here to a similar thing like here. Yeah, this is like so weird at this point. to me to read, and then they call the mem equal u8 and then memspan x0, which is this one, this variable. They take the first element and they take the optional out of it, and they compare it with the string window name. And they expect it to be true, I believe, yes, because it passed the test. Yes, so weird. So first of all, to me, this is weird that if you just say dot question mark, that you are getting this. I would have guessed that it's a type. And then that you have to... actually, yeah, it's a different thing. I've never seen dot question mark alone. The previous examples were like dot question dot star. So it's a different thing. Okay, okay. Let me see what you're writing. To be honest, this you will never encounter. Yeah. So yeah, this is like those weird parts of the language that are highly unlikely to be used in the real world, but they can help to understand things, but not at this level where I'm at, like my current level. So it's very hard for me to understand. So I would probably have to spend like 15-20 minutes on this expression only, and to dig into the docs and to understand it fully, and also to play and print things and see like piece by piece, deconstruct it and see what I get to understand. So then I will not spend my time now on this and trying to understand this. Let's go to the next example. Type coercion integer. And what was the point here? Just to read one more time. Pointers coerce to const optional pointers. Okay. This is just like a funny way for me to say that what they just said. I mean, this entire thing. Okay. The next thing. Type coercion integer and float widening. Coerce to integer types which can represent every value of the old type, and likewise floats coerce to float types which can represent every value of the old type. Yeah, so kind of understood what they want to say. It's from smaller to bigger, let's say. My own words. So what they say here, bunch of variables that are increasing in size in every row. So 250, okay, it can fit U8. Then U16 from that, which is even larger, then U32 even larger and larger, 64. 64 is the same in E, so from D to E, they don't expand U64, they use the same type. Then they expand to 128. Then they expect F to be equal to A. Okay, so this is integer widening, that's how they call it. Implicit unsigned integer to signed integer. Yeah, so now you have to be careful for the size, always like double the size, right? So U8 only into U16 or bigger, not be U8 to I8. Float widening. Let's see, the same thing basically. So they start with F16, which I believe is the smallest float type. Then they go to F32 from there. Then they convert F32 to 64. Then 64 to 128 finally. And they didn't use here the 80, but I guess F80 would be the same. Then they expect and already can tell here that everything passed, so everything equals. Let me see what you wrote. Even in most C interop. Also, dot question dot star is combination of dot question mark, nullable unwrap, and on that unwrapped value, make a pointer dereference. Aha, it's kind of like, okay. So I was just like thinking it's not the first step like this, what you explained. It helps a lot because I thought it was just like something like a nested struct or something, that when you do a dot question mark, that part first, they don't necessarily unwrap. But now, yeah, it makes more sense. So you first unwrap and then go deeper into that unwrapped thing that you have. to go dot star. Okay. Yeah, I didn't expect, because usually I'm accustomed when I see, for example, I expect unwrapping. Usually when I see parentheses, so when there is like a function that will do that. And for the pointers, I still have to get used to these pointers that do unwrap. And when they unwrap. That's just like how my mind works, and how when I see visually something, what I think. So when I see something like a dot notation, and then because this is the weird part for me, that I don't remember seeing this before. Maybe I missed something. Like I don't, of course, I never went and learned everything that you can learn for any of the languages that I've learned. I've just like learned the things that I want to use. And maybe even like at the beginning when I learn a language, when I watch a tutorial or something, maybe I even learned something similar in some other language, but if I don't use it, I forget completely that it exists. So in this case, like in my mind, when I see dot notation something, it's usually kind of like nested object, because I usually work with objects, not with structs. And okay, in Rust there are structs, but in other languages that I use, mostly there are objects there. And when you do dot notation, it's like the nested child object, or a function, or a method, not a function, and so on. But this is the weird part for me, that like a dot question mark, you have that's kind of like the operator that unwraps. It's not like that you have an object that's nested, so that's why I wasn't expecting it. Overall use dot question mark only if you know it's not null. Otherwise you'll use if. Okay. Got it. Thanks again. Okay, let's see. Float to integer on compiler error is appropriate because this ambiguous expression leaves the compiler two choices about the coercion. See the example. Okay, let's first read what they say, and then I will read the example. So cast 54.0 to comptime int, resulting as comptime int from 10. Okay, which is casted to as f32 from 10. Cast 5 to comptime int, resulting as comptime float 10.8, which is casted to as f32 10.8. Okay, let's see. Because they have here the division part, and here they say f32. That's why they have these f32s here, and then here the nominator denominator. I always confuse this in English because I didn't learn math in English. But the one that is above is float, and then here this one is 5. Okay. And then they say ambiguous coercion of division operands, comptime float and comptime int non-zero remain. Okay. Yeah, comptime float, comptime int. And they don't know what to do with it. Okay. Type coercion slices, arrays and pointers. A lot of things happening here. See pointers after that. And coercion optionals. I just want to see how many things are left. Optional work nested inside area and type. Type coercion area unions. Type coercion, yeah, a lot of things. Coercion unions and enums. Defined. 2+2 arrays. Explicit casts. Oh, pure type. Yeah, that's what they mentioned a few minutes ago. Yeah, this is too long, so I will not definitely do this today. So let me see if it makes sense to pause somewhere. So I did this. Float int is the last one, right? This is where we stopped. So maybe I'll just do slices, arrays, and pointers, this part. And then I will stop before optional coercion. I mean, coercion of optionals. And let's see. Okay, so that's okay. So then equality, they usually say equal when they want to have the true as the output. Usually they don't fail the tests for that. They fail it in a different way. Okay, I'll do it here. I'll not run it, just try to figure out how it works. Okay. So this is kind of redundant. I copy paste too much. Have it here. If I decide to run that, I will probably not. You can assign const pointers to arrays to a slice with const modifier. So let's repeat this. You can assign constant pointers to arrays to slice, like why this transitivity to arrays to a slice. Aha, okay, this is the type. Okay, constant pointers to arrays. Okay, I was reading it wrong. So you can assign constant pointers to arrays to a slice with const modifier on the element type. Useful in particular for string literals. Okay. Const x1. Okay, it's a slice of u8s, right? And then the second thing is explicitly saying the array of size 5 and then address of it. And this is basically what they say. So constant pointer to arrays, which is this basically, because you add the reference operator, or how they call it, address of operator. And then this should be then constant pointer to arrays, and you cast it to actually coerce, right? That's how they say, to constant slice of u8 slice, or however you. I'm struggling, like how to organize, how to order the words at slice. Okay, of u8s. Then they expect this to equal, and it is okay. Then what they do with this float example, const f32 slice. Oh, well, basically the same thing. They just have like different literals here. And then in this case, they just like don't compare the entire thing if they're the same, but they just take the first one with 0. Okay, so this was cost nt to aha. So this is basically when they want to say this. Let me see what you wrote. I see some smileys. Should be interesting. Where I paused first. I mean, where I stopped before. What was the last comment that I read? Aha, yes. Otherwise, you use if. It might not seem like it, but Zig is actually really simple language. It has some low-level stuff, but feature, keyword count, and complexity is low. Yeah. So no, it makes sense now that you explained that most of these things that are like so hard to understand are basically for interoperability with C, so that you actually don't need them if you don't want to do like Zig plus C in your projects for some either, let's say, legacy reasons, or maybe to just like, well, what I can imagine that could be a use case scenario. For example, Python has multiple implementations, and the most common one is written in C. So I believe it's called C Python. So if you download it from python.org, that's the one that you're going to get. And it's written in C. So you have some libraries which are optimized because Python is very slow if you do everything in Python way. If you just like use this dynamic typing and everything that Python does. So one example, you have a list in Python. They don't use arrays out of the box. and you have a list which is basically like an array, but it can have different types. So in Python you can have I'm not Robert, sorry if you know Python, I'm just like trying to also explain if someone is watching it and if they don't know how it works in Python. So you have a list that can contain different types. So you can have a list that has one integer, one float, one string, and so on. So even more complex types. You can even nest lists within lists which have also numbers and so on. So for this reason, if you do a loop, for example, then under the hood, Python has to check what is the type. So it's interpreted, so there is no compilation. So during the runtime, it will check like, what is this? For example, you want to say in a loop, take the element of a list and multiply by 2. So it has to see what is the type of the current element, then to call the appropriate function under the hood in C, because it's written in C. So if it's an integer, it will call one that will do that operation with integers. If it's, I don't know, a float, it will call a float. And it gets even more complicated if you use like plus operator, which can be also used with strings. So a lot of complexity under the hood. And because of this, it's very slow. So it has to check the type, it has to call a specific function, and it will repeat this even if you have, for example, all integers in a list. It will do that over and over again. And that's why it's extremely slow. So that's why if you do, for example, data science in Python, if you use just Python without any libraries that are optimized, you are going to wait. I literally had a student, so she's doing her PhD, and she did some calculations, and she did it in this way. She used the for loop in Python, and she waited like 5 hours for some results of some calculation because she has like, I don't know, 100,000 rows of data that she needs to transform in this way. So this is, let's say, the pure Python way. But of course, because Python is widely used for data science, then when they see that they need to optimize for something, let's say you want to multiply only integers in a specific case, and you want to avoid this type check and everything. So then they under the hood, they use some libraries like NumPy and Pandas that are optimized, also written in C again, but they are optimized because they don't allow you. So that now you work with arrays, or in case of NumPy, or with the series or data frames if you work with Pandas. Basically, under the hood, it's arrays. It's C arrays, and they're the same type. So you're avoiding these problems. So they don't allow you to have to put like Python lists. So it's still Python, you write Python code, but the data structure that you're using is not allowing you to put different types. It's always the same type, which saves a lot of this time, and hence it works much, much faster. So then literally the same person that I mentioned before, who had to wait like 5 hours or so, I don't remember exactly, for results, when I showed her how to do it with Pandas, so use Python, one line of code, nothing out of Python, then she got the results like in 5 minutes or so. Less, I don't remember. So it was literally like visible. You run it and you can wait for it without a problem. So this is the why I go too wide. I just wanted to make a point, but I went too wide. So the point was supposed to be that I can imagine, like in Python, it's already done many different times. So if you need a data science library, now you have variety of options. So you have already something that is optimized for speed. So you don't have to write it yourself. But I guess, for example, if you wanted to write a library for Python in Zig, because there is no Zig implementation of Python, so you cannot use Zig in this case, where you will avoid these kind of things that are complex, that are because of C, then you will still have to, but you have a way. That's important. So that if you wanted to make nowadays a library for Python that you want to write it in Zig, you have a whole way of doing it. So this means a lot for the adaptability and everything. And you can do some very interesting projects. And not only for Python, I just gave an example for Python, how it can be useful, that you have this integration with C, and that you have a way of writing something that you don't have in the ecosystem for also different languages, not necessarily only Python. Python is already like oversaturated. It has basically everything you need. There is a library for it. But also it can be an example when you do WebAssembly. you can do a lot of interesting things with WebAssembly. I did some WebAssembly like 7 years ago with Rust, but I would definitely. So today someone asked if I will do some project, let's say real world project, and I answered that I will do probably for starters I will do just like for fun some Zig projects that I don't intend to implement. But if I were to think about something that I would prefer to do like a real world useful thing, it would be something related to WebAssembly because I'm a web developer. So for me, this is, let's say, the focus. It is still assembly, right? So it runs in modern browsers along with JavaScript, the second engine. So before 2017, if I'm not mistaken, all the browsers, the main ones at least, they had only JavaScript engine to run it in the browser, like front end. But since 2017, literally like Chrome, Mozilla Firefox, Safari on macOS, and Edge in Microsoft, so they all agreed that they will put this engine for WebAssembly, which is like assembly for a virtual non-existing computer. And it's kind of unified, that's the point, so that you don't have to learn assembly for this processor or for that processor. You actually don't write a WebAssembly, so it's kind of like a sweet compilation target so that you use Rust and Go, and so when they use Go, they use this specific version because Go is garbage collected, and then the binary that you make, even hello world, will be like 2 megabytes. It's huge for web, just to say hello. So they use I think it's called TinyGo. I never did it with Go, so I don't remember, but I think it's called TinyGo. So it's kind of like a Go compiler that doesn't compile, that doesn't include the garbage collector. I don't know how it works because Go is designed with the garbage collection, but in this case, this compiler does something differently. I don't know. I've never used it, so that's why I don't know. So this is something that I would prefer probably to do something in Zig. If it's for real world application, I will see that I do something that I compile Zig to WebAssembly and then do something with it, process something alongside with JavaScript and so on. Let me see. Yeah, I'm talking too much probably. Sorry for that, I'm off topic, but it's kind of on topic as well in the same time because we speak about the use cases of Zig, which could be interesting to a lot of people. Let's see where I stopped with reading your comments. Sorry, Robert. You can chain combine, but no, is this the one? Yeah, it may not seem like actually really simple language. Yeah, this is the last I read. You can chain and combine, but individually are simple, and even when combined, it scales linearly. Not like Rust exponential scaling of lifetimes combination. Yeah, for me, Rust lifetimes were not so difficult because people were speaking about them, and I was expecting I'm going to die like learning them. For me, like it's more like traits and what traits do in Rust. If you want to go deep and use them in a good way, because with lifetimes in the real world. So I'm not saying if I were to design something from scratch, some huge project, probably then lifetimes would be more complicated to work with. But when you use frameworks, you kind of just like learn. Here you have to use a lifetime because it's expected, otherwise it will not compile, and you kind of like learn these spots which lifetimes you have to. So you don't write from scratch things. I mean, in my job I didn't. So for the guys, it's a different story if someone is writing something like a low-level thing that is from scratch, then it's a different thing. Then it will probably be more complex. And generative macros, yeah. Deja vu to tic-tac-toe. Yeah, deja vu, a lot of deja vu. Yet after starting day 16, a lot of deja vus from previous 2 hours of, not 2 hours, but an hour and a half coding. The classical boxed values, and that is why you import matplotlib arrays. Yeah, so numpy arrays, yeah. Numpy, I forgot the name. Yeah, matplotlib, yeah, you're right. It's for visualizing things. So when you want to literally like to plot the graphs, whatever kind of graph you want, they have it. NumPy is a mathematical library. So it's most important for the arrays because that's what they say. I mean, to me and to what I have done. I'm not saying if some mathematician will use it, they will use it completely like more than I do, and they will go and use all the parts that you can imagine in NumPy. But mostly for data science, it's crucial to understand NumPy arrays because they are underlying type when you work with pandas, which is the science library of the most commonly used data science library for general purpose. So if you're not using something, if you're using like, I don't know, specific machine learning or something specific, you have specific libraries, and but in general, like data processing and this kind of data science, like to more process the data than to in general, it's the most commonly used, and they are based on top of, so they literally like built their types on top of NumPy arrays. So basically you can do everything that you can with NumPy arrays, plus you have additional functionality and things. That's why NumPy. And when you install pandas, you get NumPy as well installed under the hood. By the way, can you can write Python libs in Zig. A lot of Python libraries use Zig to compile their C++ code for Python. Yeah, literally, like, yeah, probably you were writing before I said it, but yeah, this is the idea that's very interesting. I encountered Zig that way as a C cross compiler. Ah, nice way to encounter Zig. Just to mention, Zig compiles natively to WebAssembly. Yeah, that's cool. And actually, the compiler is bootstrapped by WebAssembly. Cool, that's cool. Yeah, no, initially WebAssembly, when I started learning it, it was mostly like the idea was to run things in the browser. But then later they introduced this, how they call it, the VASI with W, that you can run also on operating systems outside the browser. So it opened up the doors to things like this. So it's much more use case scenarios than just like running something in the browser for performance. Lifetimes are simple until you need to combine them with other parts, like I think. Yeah. So this is true. Back to Rust. Yeah. So if you want to do something from scratch, for sure, they will be much more complicated. I use them, so I play them with there is this framework called Anchor for Solana. So it's Rust, but a framework is called Anchor, and they have some lifetimes there. But you just basically learn like, okay, I need to provide here the lifetime for this function for it to work and so on for the parameter. Okay, let's see where I stopped here with Zig. I believe here. So they did the same thing. Yeah, I just realized they are taking the first value here. Likewise, it works when the destination type is an error union. Okay, any error union with the slice U8, the slice of okay, hello. Okay, so either error or this thing. The second one are the same, but they just used explicitly as an array here instead of string literal. And they are the same. Okay, then any error. Again, the union with a different type with the floats. Okay, basically the same thing. So in this case, they are just like taking the type, the source type, let's say like that, and then because they call destination, that's source. That's why I said source, and they're just doing it to. They're putting it inside of the union, let's say like that, in a vulgar way. So the next one works when the destination is an optional. Yeah, so we had something similar before. And again, pretty much the same thing. Just in this case, it's an optional. So So in my mind, how I imagine like the optional versus the union. So this is kind of like the union, but you are making a union between the null and this type. So that's why I'm kind of imagining a union where you say null here on the left, just to memorize it easier. And the same example. So first they do that with the string literal, and then with the explicit array, where they do the same string inside as an array explicitly. And then there is this dot question mark to unwrap. Okay. Then the same thing here for the float. In this case, the array length becomes the slice length. Okay, let's see what they do. Var buff, which is a slice. And then they take the hello string dot star. Oh no, this is not a slice, sorry. This is the array. Then here they take the address of it, and then they coerce it to a slice. Okay. And then the array length because the slime select. Okay. Yeah, so this is, yeah, now it kind of makes more sense when they say like a slice is array plus the length, because literally in this example, when they do it, they are, I mean, visually you can see that 5 is gone. And then they see the x equals hello. Okay. And then I guess the same thing, but with a different kind of array. Yeah, these are floats instead of string literal. Again, coercion to slice of F32s, and they are equal. Aha, okay, in this case, just yeah, actually it's the same thing, but just a different type. And since here it's a string literal that they are asking for equality, that's why they don't use the address of operator. Okay. Single item pointers to arrays can be coerced to many items, yeah, because they're larger. I mean, the many items are larger type. So they take first hello literal dot star. They make array out of it, and then they take the address of, and they use this star, which I again find very weird. So basically this is just pointing to a first character, sorry, to the last character, not first. And then what they say, I would be an uncaught out-of-bound pointer dereference. That's cool because they don't take the terminator. Okay. Likewise, it works when the destination type is optional. So the same example like before at the beginning, but then they just make it an optional here. This is the only thing that is different. And they, of course, here access it. First they unwrap it, and then they take 4, index 4. Okay. Single item pointers can be cast to length 1 single item arrays. Okay. So here it's explicitly said it's 1. So first let's start. They say x equals i32, so this is the number, which is i32, which is 4 bytes. Then they take just the first one here. At first address of x, okay. Then they make z, which is then tested here for the okay, this is the part. So I was thinking how can it be equal to 1 2 3 4, but I overlooked the square bracket 0. Okay. Okay, still a bit confusing, but I will get used to it. Okay, I will stop here for today. Let me just like read the comments before I go. And the last thing I've read. Okay, WebAssembly lifetimes are simple. Yeah, this is the last thing that I read about lifetimes. That was nice visit of 5 languages. Yeah. I'm like a senile old person when they start speaking and they don't even remember where they started the story. Uni is not the best way to imagine nullability. There is generally a single bit that signalizes whether it's null or not. Units are C concept for usage of single memory space to represent more possible data types. It's genius concept, but came from C. Yeah, it's cool. Not that I kind of like hate C. I just think it's too hard to do some things in, let's say, safe way. Just for the conclusion, you generally don't use these type pointers that which have star between the square brackets. Okay, okay, nice. Yeah, it was an interesting day. So tomorrow I will continue. I already forgot what was the next thing in the docs, but with the next thing in the docs. So day 17, next things from the docs tomorrow. Thank you guys for being here today. Thank you, Robert, for being so active. And I guess I'll see you tomorrow if you will make it. That is a multi-item single pointer without a length. Yes, thank you. I'm still confusing them. I know that I looked like 5 times for sure into that explanation in the docs, but still I have to memorize by using. Thank you one more time and see you tomorrow. Bye bye. Have a nice one.